Jupiter, the massive giant of our solar system, stands as a true testament to the extraordinary wonders of the cosmos. With a diameter of around 140,000 kilometers, it's a planet so massive that the Earth would fit inside it more than 1,300 times. It's a world that is so vast, so powerful, and so mysterious that it captivates the imagination of astronomers and space enthusiasts alike. Jupiter isn't just the largest planet in our solar system, it's the dominant force that shapes much of the dynamic behavior within our planetary system. It is 2.5 times more massive than all of the other planets in the solar system combined, which makes it the undisputed giant. But despite its overwhelming size, there's more to Jupiter than just its immensity. The planet spins faster than any other planet, completing one full rotation in less than 10 hours. Its rapid rotation creates incredible forces that shape its atmosphere and give rise to some of the most fascinating weather phenomena known to science. One of the most remarkable features of Jupiter is its Great Red Spot, a storm so large that it could easily swallow Earth whole. This storm has been raging for at least 350 years, possibly much longer, and it continues to baffle scientists with its persistence and intensity. Winds inside the Great Red Spot can reach speeds of up to 680 kilometers per hour, making it the most powerful storm in the entire solar system. But while the Great Red Spot is one of the most famous features of Jupiter, it's far from the only one. The planet's entire atmosphere is a swirling maelstrom of clouds, belts, and zones, constantly in motion. These weather patterns have fascinated scientists for centuries, and we are still learning new things about how they work. The composition of Jupiter's clouds, the materials that make up its belts, and the chemical processes that drive its storms are just a few of the mysteries that scientists are eager to uncover. Despite its massive size and powerful storms, Jupiter is not just a spectacle of nature. It plays a pivotal role in the history and evolution of our solar system. In fact, Jupiter may have been one of the key factors that allowed Earth to form as we know it. Scientists believe that the planet's immense gravitational influence helped to shape the orbits of other planets and prevent catastrophic collisions with comets and asteroids. It's thought that in the early days of the solar system, Jupiter's migration through the inner solar system may have scattered debris and cleared the way for the formation of smaller, rocky planets like Earth. Without Jupiter's gravitational influence, Earth might not have formed in the first place, or it might have ended up as a vastly different planet. Jupiter's formation and evolution are just as fascinating as its current state. Scientists have long been trying to piece together the story of how this gas giant came into being, and recent advancements in our understanding of planetary science have helped to shed light on some of the more mysterious aspects of Jupiter's past. One of the most important discoveries came from a study conducted by researchers at the University of Beast, who successfully determined the true age of Jupiter. Because Jupiter is made of gases and lacks a solid surface, it is difficult to directly date the planet. Instead, scientists have used asteroids and meteorites as a proxy for understanding the planet's history. These studies have shown that Jupiter likely reached a mass of 20 Earths in less than 1,000,000 years after the formation of the solar system, and its development was completed within another 3 million years. In comparison, Earth, which is much smaller, took around 100 million years to reach its present state. Jupiter's role in shaping the solar system goes beyond just its formation. Its gravitational influence has been crucial in determining the orbits of other planets and keeping the solar system stable. In fact, Jupiter's powerful gravity has acted as a kind of cosmic shield, protecting Earth and other planets from potential impacts by comets and asteroids. Jupiter's massive gravitational field can redirect objects that might otherwise collide with Earth, ensuring that our planet remains in a relatively stable orbit. This protective role has been one of the key factors in making Earth a safe and habitable place for life to flourish. But Jupiter's influence is not always benevolent. In some cases, its gravity has caused smaller planets to be ejected from the habitable zone, making it more difficult for life to form on those planets. There is also evidence that Jupiter may have once been positioned much farther from the Sun, and that it may have migrated inward, causing chaos in the inner solar system. This migration could have scattered large amounts of debris and disrupted the orbits of other planets, including Earth. However, this violent migration of Jupiter also cleared the way for the formation of smaller planets like Earth, as it prevented larger objects from interfering with the process of planetary accretion. Jupiter's immense size and mass make it one of the most significant objects in the solar system, and its gravitational influence continues to shape the structure of the entire system. The planet is also home to an astonishing array of moons, with at least 95 moons currently confirmed to be in orbit around Jupiter. Some of these moons are truly remarkable, with features like icy surfaces, volcanic activity, and even subsurface oceans. One of the most exciting moons in Jupiter's system is Europa, which is thought to have a liquid water ocean beneath its icy crust. This ocean is a potential habitat for extraterrestrial life, and scientists are eager to explore Europa further to learn more about its potential for supporting life. NASA's Juno spacecraft, which is currently orbiting Jupiter, is tasked with studying the planet's atmosphere, magnetosphere, and moons in greater detail. The mission has already made some exciting discoveries, including new insights into the structure of Jupiter's clouds and the composition of its magnetic field. The European Space Agency's JUICE mission, which launched in April 2023, is set to arrive at Jupiter in 2031 and will conduct a comprehensive study of the planet and its moons. This mission will provide even more detailed information about Jupiter's moons, especially Europa, and could help to answer the question of whether or not life exists elsewhere in our solar system. One of the most intriguing aspects of Jupiter is its magnetosphere, which is the largest and most powerful of any planet in the solar system. The magnetosphere extends millions of kilometers into space and is so vast that it could contain all of the other planets in the solar system. Jupiter's strong magnetic field is created by the planet's rapid rotation and its liquid metallic hydrogen core, which generates electric currents. These currents produce a magnetic field that is 20,000 times stronger than Earth's. Jupiter's magnetosphere is constantly interacting with the solar wind, the stream of charged particles emitted by the Sun. This interaction creates a range of fascinating phenomena, including powerful auroras at Jupiter's poles and massive radiation belts that pose a significant danger to spacecraft. The radiation environment around Jupiter is so intense that it can damage the electronics of spacecraft and satellites, making it one of the most hazardous regions of the solar system for space exploration. Jupiter's iconic appearance is another feature that sets it apart from other planets. When viewed through a telescope, Jupiter is immediately recognizable by its distinctive bands of clouds, which appear in a series of light and dark stripes. These bands are the result of different layers of clouds, each with a different chemical composition and temperature. The lighter bands are typically made of ammonia ice, while the darker bands contain more complex compounds like phosphorus, sulfur, and hydrocarbons. The interaction between these different bands of clouds creates turbulence and wind patterns that contribute to the planet's dynamic weather systems. The dark belts and light zones on Jupiter's surface are constantly shifting, changing in response to the planet's internal dynamics and external forces like the solar wind. These changes are not just superficial, they have a profound impact on the planet's weather, including the formation of massive storms like the Great Red Spot. The Great Red Spot itself is one of Jupiter's most famous and mysterious features. This storm has been raging for centuries, possibly even longer, and its exact origins are still unknown. The storm is an anticyclone, meaning that it rotates in the opposite direction of most storms on Earth. The winds inside the Great Red Spot can reach speeds of up to 680 km per hour, making it the most powerful storm in the solar system. The storm is so large that it could easily contain Earth, and yet it has persisted for centuries. However, recent observations show that the Great Red Spot is gradually shrinking, and scientists are trying to understand why. Some believe that the storm may eventually dissipate entirely, while others think that it could continue to exist for many more centuries. One of the most fascinating aspects of the Great Red Spot is its shifting appearance. Through observations made with the Hubble Space Telescope, scientists have discovered that the storm changes shape and size as it moves across the planet's surface. The storm's eye, the calm center of the storm, expands and contracts, and its color changes as well, becoming brighter or darker depending on the storm's speed and intensity. This swirling, chaotic beauty is one of the things that makes Jupiter so captivating. But beyond the awe-inspiring visuals, Jupiter's atmosphere is a source of endless scientific interest. The planet's rapid rotation, powerful storms, and intricate cloud structures create a dynamic environment that is constantly evolving. Scientists are using advanced instruments and space missions to study these changes in greater detail, hoping to unlock the secrets of Jupiter's complex weather systems and atmospheric chemistry. The data collected from missions like Juno and JUICE will help to answer questions about the planet's formation, its interior structure, and the nature of its weather. But perhaps the most intriguing question of all is whether or not Jupiter's moons could harbor life. Europa, with its subsurface ocean, is one of the top targets for astrobiological research, and future missions to Jupiter's moons could help answer this question once and for all. Jupiter is a planet of extremes, and as we continue to study it, we're only scratching the surface of its many mysteries. From its rapid rotation to its massive storms, from its vast magnetosphere to its potential for harboring life on its moons, Jupiter continues to captivate the imagination and challenge our understanding of the universe. So, as we look toward the future of space exploration, one thing is clear: Jupiter will remain a central focus for scientists and space enthusiasts alike, offering endless opportunities for discovery and wonder.